In this lecture, we'll be discussing about operating system design and implementation. So we will be mainly talking about the design and implementation of operating system and what are the things that we need to keep in mind if we are designing and implementing an operating system. So talking about the design goals, the first problem that we face in design goals are defining the goals and specification. Now, why this is a problem? This is a problem because it is not very easy to specify all the goals and specifications that we need for an operating system. That is because depending on the kind of users and depending on the kind of system requirements that we have, there may be different set of requirements and goals that will be there. And it is not actually possible to fulfill all those goals and requirements. So that is why we call it as a problem. Now, talking about some of the requirements which we can specify, two of them are the choice of hardware and then the type of system. So by choice of hardware, what we mean is the kind of hardware that we are going to choose on which we are going to build our operating system. And then the type of system. So we have discussed about a few kinds of system or few types of system in our previous lectures. So it may include multiprocessing systems, multitasking systems, real-time systems, and so on. So we can specify the choice of hardware and then the type of system that we need. So these are two requirements which we can actually specify. But beyond this highest level design, the requirements may be much harder to specify. Now beyond this, the kind of requirements that they have, it may be difficult to specify and it may be difficult to achieve all of those requirements. Now let us see what are the kind of requirements that are there. So there are requirements from the users and then there are requirements from the system. So we call them as user goals and system goals. So user goals are the requirements that are there from the user's perspective or from the user's side. And then system goals are the requirements which are there from the system or from the developers that are developing or designing the system. Now let us see what are the requirements that are generally there from the user and from the designers. So from the user side, we have the user requirements or the user goals. Now, what are the user goals or the requirements from the user side? The user, he wants the system to be convenient to use, easy to learn and use, reliable, safe and fast. So these are some of the requirements that are there from the user side. Now let us see what are the system goals or the requirements from the designers or the developers which should be there in the system. So from the designer side, he also has some requirements. So we call it designers or engineers requirements, or we call it as the system goals. So in the system goals, this designer, he wants the system to be easy to design and implement, maintain and operate, and it should be flexible, reliable, error-free and efficient. So these are some of the requirements from the system side. Now if we look at this, these are some very general terms or very vague terms. So we actually don't have any particular formula or a particular principle that we can follow in order to achieve all these requirements. So there are no particular rules or there are no particular set of instructions that we need to follow in order to make the system easy to learn and use or convenient to use or easy to design or something like that. So in short, we can say that there is no particular solution to specify or to meet all the requirements that are there in designing an operating system. But there are some principles and rules that are actually followed in order to meet at least some of the requirements or to make the operating system as good as it can be. So these are discussed in the subject of software engineering, which you might have studied or which you will be studying in the future. So in the software engineering, there are some principles that they follow in order to achieve some of the requirements which are there, or at least most of the requirements that are there in this designing. So talking about the software engineering, let us now try to understand the mechanisms and policies involved in that. So now we'll be talking about mechanisms and policies. So first, let us try to understand what are mechanisms and what are policies. So we see that mechanism determines how to do something, while policies determines what will be done. So mechanisms determine how to do something, how a particular thing has to be done. That is what we mean by mechanism. And what will actually be done, that is what we mean by policies. Now, in order to understand this, let me take a simple example from our day-to-day life. So let us say that you are driving a car Now for driving a car, when you are driving a car, there are some mechanisms going on inside the car which is helping the car to move forward. So that is a mechanism that helps in the working of the car. So that is the mechanism. Now let us say that you are driving your car on a route where there is a rule which says that you should not exceed the speed of 50 kilometers per hour. Now that is a policy. There is a policy, that is a rule telling you that you should not exceed 50 kilometers per hour. And then how you maintain that 50 kilometers per hour in your car while you are driving, that is the mechanism, the working or the mechanism that helps the car in order to maintain that speed and helps in the working of the car. That is the mechanism. So I hope that helps us to understand what is mechanism and what is policies. So coming back to our operating system again, there is an important principle which says that it is always good to separate our policy from mechanism. One important principle is the separation of policy from mechanism. Now why is this required? Let us come back to our example of the car again. Now let's say that in the first case you are having your mechanism and policy separate. So let's see why this is good and why this is flexible. Now you are driving that same car through another route now. And in that other route, it says that you should not exceed the speed of 40 kilometers per hour. So before you were driving at a speed of 50 kilometers per hour, now you are told to drive at 40 kilometers per hour. Now you need to slow down your speed. So for doing that, you don't have to change the mechanism of your car. You can just slow down your speed to 40 kilometers per hour, but the mechanism of how the car works, it still remains the same. So the mechanism is not affected by the change in policy that we have. Now let's say that in the other case, you are having your mechanism and policy as one unit as shown over here. So if this is the case, what happens is that your car is designed to run at 50 kilometers per hour. Now when there is a new policy which says that you have to slow down to 40 kilometers per hour, then along with the policy you have to change the mechanism as well, which is very bad. That is because if you have a different policy, you have to change the entire mechanism of your car, which is not flexible, which is not practical, and which is not efficient. So from there we can understand why it is important to have policy and mechanism separate. So the change in policy will not affect the mechanism of your operating system. So let us take an example in terms of operating systems, because we were talking about cars till now. So let's say that we have a simple example of resource allocation. So we have already talked about resource allocation. So resource allocation means a process needs a particular resource, so it requests for that resource, and then the resource has to be allocated to the process. Now when a process requests for a resource, how that resource will be allocated to the process, that is your mechanism. And then the policy determines what will be done. The policy will determine whether to allocate the resource to that process or not. So that is your policy. So the way of allocating the resource to a process, that is your mechanism, that should always remain the same. It should not be changed. But whether that resource will actually be allocated to the process, that will be determined by the policy. So sometimes according to the policy, a resource may be allocated, or sometimes it may not be allocated. So a change in policy should not affect the mechanism of your operating system. That is why we have this important principle which says it is always good to separate your policy from mechanism. Alright, now we have talked about designing, and we have also talked about mechanisms and policies. Now after you have done all this, after you have designed your operating system, the final thing that you have to do is you have to implement your operating system. Now let's see how do we implement our operating system. So coming to the implementation, once an operating system is designed, it must be implemented. Of course, it must be implemented for it to work. Now, traditionally, operating systems have been written in assembly languages. So the first operating systems that were there, they were mainly written in assembly languages. So if you have used assembly languages or studied about assembly languages, you know that it is not very easy to write assembly languages. It is long and it is complicated. But now, however, they are most commonly written in higher level languages such as C or C++. But the operating systems that we have now, they are mostly written in higher level languages such as C or C++. Now let us see what are the advantages of writing our operating system in higher level languages and not in assembly language. So these are some of the advantages of writing your operating system in higher level languages like C or C++. So first one is the code can be written faster. So if you have done assembly language coding, then you know that it is not very easy to write in assembly languages. But if you switch to higher level languages like C or C++, it will be easier and also faster to write it in this kind of higher level languages. And it is more compact. It is more compact because you don't have to write too many things as compared to the assembly languages when you write in higher level languages. And it is easier to understand and debug. So if you are writing your program in higher level languages, it will be easier to understand. Even if another person is reading the codes that is written by you, we know that it is not very hard to understand if it is written in C or C++ or something like that. And if there are some kind of errors, it will be easy to debug as it is written in this kind of high level languages. And then it says it is easier to port. And by easier to port, we mean that it will be easier to port the operating system from one hardware to another hardware. Now the problem or disadvantage of writing in assembly language is that if you have written a operating system in assembly language, then that operating system will be supported only in those hardware which are fitted with the processors or the CPU families similar to the one in which you have written your operating system. Like for example, the Microsoft DOS, MS-DOS, which stands for Microsoft Disk Operating System, which is an old operating system, it was written in Intel 8088 assembly language. And because of this, it is available only on the Intel family of CPUs. So since MS-DOS was written in the Intel 8088 assembly language, so it is supported only on the Intel family of CPUs. So the CPUs from the Intel families are the only ones that supports the operating system MS-DOS. But the Linux operating system, in contrast, it is written mostly in C and is available on a number of different CPUs including Intel, Motorola, SPARC, MIPS and so on. So Linux operating system, on the other hand, as it is written in C, which is a higher level language, it is available on a variety of CPUs. So this is the advantage. So that is the example of portability. It is easy to port if you are writing it in higher level languages. Alright, so that was about the implementation of your operating system. So we discussed about designing, policies and mechanisms, and implementation of operating system. So when we talk about designing operating system, it is a vast task and it is not something that can be achieved by following some set of rules, or there is no particular textbook that will tell you how to do it in order to specify all the design goals and to achieve all of them. So depending on the kind of requirements and the kind of system that you are developing, you will need to use your creativity in order to design it in the best possible way. So I hope that was clear to you. That was about the designing and implementation of operating systems. So thank you for watching and see you in the next one.